Good morning, good afternoon, and good evening if there's anyone joining from Europe. My name is Lulu Arias. I'm Xendee's Director of Customer Success, and I'm pleased to be co-hosting this webinar with Ed from Jenbacher. So this is our agenda for today. We will start with some introductions, then I'll tell you a little bit about Xendee and our design tool. After that, I'll pass it over to Ed, who will tell us about Jenbacher and will showcase one of their projects using design. And after that, we'll close our time together with some Q&A. And please feel free to leave your questions clicking the Q&A button throughout the webinar, and we'll answer them at the end. Okay, so as I mentioned before, I'm Lulu Arias. I'm the Director of Customer Success here at Xendee. Before joining Xendee, I used to work at the Boston Consulting Group, leading teams on various projects, but mainly focused in mining and oil and gas. And that's one of the main reasons why I decided to join Xendee, to transition into green energy and contribute to having positive impact in the world. I joined Xendee a year and a half ago, and since then I've been working closely with customers, helping them optimize their microgrids and EV infrastructure. And I've also created spaces like this to allow customers to showcase their use cases. Ed, I'll let you introduce yourself.
Hi, good morning, good afternoon. Thank you, Lulu. Ed Alcorta. So I've been in the industry for 15, 20 years now, in the energy industry overall. A lot of the work with turbine OEMs, recip engine OEMs, including the last 12 years, with INNIO, previously GE Power, some of the time with the Waukesha product lines, some of it with the Jenbacher product line, last couple of years with Northeast Western Energy Systems, the largest Jenbacher distributor in the US, and recently acquired last year by INNIO. So back in the family. I am now the Director of Application and Solutions Engineering.
Thanks, Ed. So for those of you who aren't familiar with Xendee, we're a software company that helps businesses optimize their microgrids. We offer 4 products that accompany you through the whole process. So from the discovery into the proposal, all the way through the detailed engineering design into the operation of the site. So let's say you have several sites that you want to decarbonize or electrify your fleet, and you need to decide where to start. Then you can use our discovery tool, where you'll enter the addresses and some information regarding the load and the technologies that you are considering, and you will get a rank order list by ROI, CO2, and other variables important to make your decision. Once you've selected the site that you want to work with, you probably need to do a proposal. And there, maybe the salesperson in charge doesn't have like the technical background outside of his or her product, or maybe you just don't want to spend so much time and resources into a project that hasn't yet been sold. In that case, you can use our proposal tool, which is catalog driven, and will allow you to quickly and accurately create feasibility studies and proposals that you can then share with prospects. Once the proposal is won, you might want to go into some more detail, and then you could use design, which is our detailed engineering tool, which allows you to do multi-year analysis, work with detailed dispatch, also model for outages, and other things that we'll see in just 1 minute. But finally, once the site is operational, you might want to continue to work with the same technology as you did before. And in that case, you can work with Operate, which uses the same algorithms as the tools that I just described, but incorporates real-time data to ensure that the runtime of your operation is constantly being optimized. Today, we will focus on design and how that fits into the Jenbacher process, but I still wanted to give you this overview so that you could see how Xendee accompanies you through the whole process. Next slide, please. So moving specifically into design, as I mentioned earlier, it's our detailed engineering design. Here you will input information about the location, tariff, the load, and the technologies that you want to work with, and Xendee will provide you the optimal technology mix. It will also provide a detailed dispatch schedule as well as a full financial analysis for the length of the project. You can work with different financing options as well as incentive programs such as demand response, grant funding, RECs, and others. You can also model for outages, either write-through or curtailment. And other interesting features are time series, which allows you to get 15-minute interval data for your analysis, and also multi-year, which allows you to input any changes that you see moving forward, such as escalation in energy prices, degradation factors, any changes that you foresee in the demand, and Xendee will incorporate it in the analysis. With design, you can also model different nodes and work with power flow analysis and one-line diagrams. That's a lot for today. I'll just pass it over to Ed, who will tell us about Jenbacher, and then go through a use case that covers some of the things that I just described.
Yeah, thank you, Lulu. Yeah, I'll go through a few slides on the INNIO and Jenbacher company overview, but intentionally want to leave really the majority of the time to go through the demonstration, kind of have that be a little bit more free flowing. But just to touch on overview of INNIO and Jenbacher and who we are. INNIO has been around many years, headquartered in Europe, in Austria. Significant presence though in the UM with the Waksha product line, as well as the Jenbacher product lines. Over 55,000 engines delivered on the Jenbacher side globally, so that's in over 100 countries, and a significant presence as well with Jenbacher in the US with over 1,000 engines delivered in North America. So very high level, just in terms of the products, pretty broad range of product portfolio on the gas engine side. A few hundred kilowatts to over 4 megawatts with single products. And then really we serve a wide range of industries and applications. Anything from commercial industrial customers, like the use case will be today for the simulation, data centers, greenhouses, microgrids of various sorts, many applications with renewable gases as well, biogas and landfill gas, full hydrogen capability. So lots of different applications and products out there that we've done globally. And then just touching on the microgrid a little bit, I didn't want to get too much into the weeds on definitions of microgrids. I know there are many out there. In a very basic and fundamental sense, really, most of the projects that we do are microgrids. But for the purposes of this specific webinar and the demonstration we'll focus on the ones with multiple DERs, or distributed energy resources. Not just a gas engine, not just a CHP unit, not just PV solar, but what do projects look like when we do a mix of them, and how do we optimize that? So that'll be the focus here. And really, in a broad sense, microgrids can have many advantages. What those are depend on exactly what the customer wants and what problem we're trying to solve for. So they tend to be unique for every project, every customer, every application. Sometimes they have similarities, but there's usually something a bit different from one to another. And then, it's one thing to simulate and model microgrids, another thing to operate and execute them. And so what we bring to the table, among other things, is the ability to do the latter, to operate them and execute the projects in the field. So one of the ways we do that is we have a INNIO proprietary microgrid controller that we can implement with our products and integrate them with other DERs up to 100. So very wide range of capabilities. That's with a local on-site controller. There's a cloud-based aspect to that as well, where there can be optimization, real-time learning, and take into account energy markets and forecasts and things like that into the mix. And another important takeaway here, though, not on the slide, is that we have the full ability to integrate with pretty much any third-party microgrid controller as well. So if the customer has one they're working with, or a developer, or an EPC, that's perfectly fine. We can integrate our technology with theirs as well. That's what we're set up to do. Okay, maybe with that, I will jump into the demonstration using Xendee before heading back over to Q&A. So the project I have here on the screen, it's a real example that we started with, and then I added a few features to it. But the customer was a real one we were working with, real problems they were trying to solve for, and the data that we started with here is real. So what I'll focus on here is kind of the way that we go about it, and it can vary from project to project too. But in this specific project, how we tend to think about them, again, just for the sake of not starting with something fresh and watching me click on things. I had one kind of pre-done here, but I'll click through our sequence and how we go about this when we model something and go through it with a customer. So the place we usually start is the electric tariff, which I'll click on here. So before getting to this point, I would have already inputted the customer site address. That's why the location shows up. With Xendee knowing the location, it knows then which electric tariffs may apply. It also knows weather data, temperature data, things like that that will matter for some of the modeling. But going back to the tariff, as you can see, that there's various screens in here. There's one showing the energy charges, another demand charges, some fixed fees and standby fees that we can get into. So lots of detail and capability in here. But I will say, especially in the US, a tool that is very handy that I tend to use is Genability. So it has a link to the Genability tool. And in here, like I mentioned, because the program knows the customer's location, it'll know the utility or sometimes utilities that serve that area. So in this case, it's PG&E. This is in California. So if I select this, it will then pull up all the possible tariffs. This utility happens to have a lot, more than most. But there's various ways to filter those. And usually by this stage, when we start talking to customer, we either know what tariff they're on because we would have been working with them and have their utility bills, or ask them, or based on their load, have a pretty good idea which couple of specific tariffs they may be on. So I won't go through the rest of the clicks here, but I knew that this one was on the B20 current tariff, so I selected that. And based on that, it will automatically pull in all these inputs here. So I didn't manually type these in. We could, if we were dealing with customers in different regions or in specific cases, I've done that as well. But in this case, it automatically pulled in all this data, as well as the different demand charges during the different time of use periods, which can get quite complex, again, especially with some of these examples in with the California utilities. They're pretty complex tariff structures. So, starting with a tariff, sometimes I start there, and other times I'll start with the load, but usually I'll start with those two things. So the customer's load can be found here. And here, again, there are various ways to input this. If we have the customer's utility data, or interval data, we call it, sometimes it's hourly, many times it's 15-minute interval data for a full year, is ideally what we like to have to model it a little bit more accurately. For that, we'll do enter load shape, which is what I did for this project. So I can upload a CSV file. Again, usually it's an hour or 15-minute data. So I upload it here, and then Xendee will take it and look at the electric only load shapes. It'll kind of compile them in week, weekend, and peak in the different months. If we don't have load data, which sometimes we don't when we first start talking to a customer, there are multiple ways to build it or simulate it. So there are NREL load shapes for different kinds of buildings, offices, warehouses, hospitals, for example. Or if we have an idea on what it may look like with a customer, like we might only know their average and peak loads, we can kind of model that if we know the type of industry it is. So we do that sometimes as well. Same on the thermal side on this one, because we wanted to model a CHP project. It has a hot water component. Doesn't have to be hot water. It could be steam. It could be chilled water. Those are applications that we can and have done in the past for projects as well. So once I've inputted the load data, something we don't need to do, but I kind of like to do is see what the load looks like when we plot it out. So there are lots of different time series files in here. Again, a lot of these are populated based on Xendee's knowledge of the temperature and the annual data. Emissions included in there. But for the load profile, I like to sometimes look at it in this view because it gives us an idea of what is going on with a customer load. So it's a lot more than what is a peak load, what is the average load. Having the load profile can be very telling, and we can zoom in on this. For example, with this customer, I can start seeing that, okay, 5 to 6 days a week, the loads are relatively steady. So it's probably working 3 shifts, right? 24 hours a day during those days. But then 1 to 2 days on the weekends, the load really drops. So it's probably not a lot of activity going on. And that's fine, but it's also good to know because it can impact what we do or what things may or may not make sense with a microgrid for this customer. So it's kind of a useful tool I like to look at and get a sense of what's going on with the customer loads. So next I start putting in technologies. So because the customer had a thermal load, I put in an existing hot water boiler, which they would have something if they have a thermal load. So this customer had a natural gas fired boiler. I put that in there as an existing one. And next I start looking at what components we would like to consider in an optimization. So in no particular order, just starting with a battery energy storage system, for example. It's pretty flexible with the kind of parameters we can put in here. We can put in estimated installed cost information. Of course, that's going to be a key factor on whether the technology is viable or not for a project, but a lot of different technical parameters, efficiencies, the C rate. So it will be a 1 hour battery, 2 or 4. We can put those inputs in here, and discrete module sizes. So this is important for a realistic look at what might make sense. So otherwise, the tool will solve for a math problem. We don't want it to tell us we want to implement a 721 kilowatt hour battery, right? We want to pick sizes that exist. So that's how we can kind of control for some of the parameters and make sure we end up with a practical solution. The PV solar side. So this is a pretty powerful tool as well. Again, this was a kind of a generic information that I put in for the inputs. So here, we put an estimated installed cost. Usually we're interested in installed cost, rough order of magnitude when we kind of do these first level feasibilities, because it's not just what the technology costs. The customer's only really at the end of the day going to be concerned with the whole project installed and turnkey costs. So that's what we try to look at when we model these, starting with very rough order of magnitude levels. So for the PV, one of the ways we tend to look at what kind of capacities might make sense is what kind of room is there. So for that, I typically use defined space. So I can go in here and I had a polygon drawn in here already, but I can go in here and select an additional one or change the size and shape on which parts of the roof could make sense, or it could be ground mounted if there's space for it. On this site there really isn't, but there's roof type arrays and ground mount that we can model, or multiple ones. So on the PV side, you can see there's different toggles on here. On other ones I had considered, and I didn't really put any bounds on them. PV one I actually did because, as is often the case, not always with the customers, but if we were going to move forward with microgrid, we wanted to include a renewable portion in there. So we wanted to go ahead and use what roof space we have available, and we can still compare what the economics can look like with and without it. Look different incentives in here, which I won't get into too much at this time. And then here, again, because Xendee knows the location, in the background it'll use PV watts, if you're familiar with that online program from NREL, to do the computations and the what energy is available for the solar performance. So that's what I use here. That's what I tend to use as kind of a first shot. If we're working with a specific manufacturer, we can put in the actual their actual calculations or actual solar panels calculations in here and upload those instead. For this case, I had to compute the type though. Okay, and then for the CHP generator. So in this case, I put in three potential gensets to pick from. So maybe one important note here, because you look at the screen and it tends to look like there's a lot going on. But we intentionally put in several models in here for it to consider. That doesn't mean that the project will automatically include all of them. The point here is to put in several sizes that might make sense for the project based on, again, what we see with the customer loads, and let the program pick which one makes more sense. So each one of these has different parameters, different attributes. Just happen to put in these three that are, a little bit different size. They have a little bit different efficiencies and characteristics. So just to click on one, for example, to see what these inputs look like, we can put in a fixed, again, turnkey installed cost of what we're trying to model. In this case, I put in nonlinear because it does make a difference if we're doing 1 unit or 3 or 5. So we can differentiate with that if we choose to. We can put in maintenance information in there as well. In this case, I did model departing load charges, which is, again, I don't want to get into the weeds too much, but with the utility as a variable maintenance charge. So it's not technically strictly for the generator, but in case you're wondering what that was. And then on the technical side, we put in the electrical efficiencies, since we are looking at combined heat and power. In this case, for hot water, we put in the heat to power ratios, again, at different loads from 50 to 100% load, so that the program has those to work with. I put in incentives. At the moment, we are running up against the tail end of the CHP incentive under the Inflation Reduction Act at a national level. Sometimes there are local incentives as well. And for CHP in the US outside of the Inflation Reduction Act, we still do have accelerated depreciation, which sometimes gets overlooked, but that can help the economics of the project as well. So it has available along with renewables still. There's more detailed information. Again, I won't get into all the details in here, but there are attributes in here that we use to make sure that it models the way that we would probably tend to normally want to see these in operation as well. Okay, and from there, we will run cases for optimization. Well, sorry, forgot to overlook one thing here. When we started talking to this customer, there was no EV demand that they had in place yet, but they were planning on it in the near future. As is the case with a lot of commercial industrial customers that we're talking to. They're either have started putting in EV chargers or are going to start or are thinking about it. So in this case, they did not have any existing yet, but we wanted to do a what if. And also just to show it for the example as well. So if I click on the EV demand, there's flexibility in the tool here as well on how we want to input the EV demand. So if the customer has existing EV demand and existing EV chargers, then we can upload what that looks like. So if they have EV chargers, we probably can get access to that data in one form or another, and we could upload it like we upload the building data. But if we don't have that, or if we're starting from nothing, like in this case, we can build it based on a pretty kind of user-friendly tool here that I've been using. So we do click on the Xendee optimized load shape, and to build a consumption or the demand profile, we click here, and then here we can really start building it up from the ground up, which is nice based on the EV fleet. And again, this is really just an example that I put in here for a demonstration, but the program's quite flexible. We can pick a lot of different kinds of vehicles in here that are already in the catalog, different quantities. And then one thing that the customer might know, especially if they have their own truck fleet that they're converting, is when are their fleets, when are they out on the road and not available at the facility? So that we can model, how many of them, what do the routes look like more or less. This will give a pretty good approximation of what, number one, what the EV profile demand might look like. And number two, when is a site available to charge them? Obviously, when they're there, right? So we put in some examples on here on different class vehicles, just to show what that would look like. But that's how we build and more often than not, when we model something that's not already existing, we go through something like this. And it's always easy enough to have a conversation with the customer on sanity checking. Does that make sense or does that not make sense for them? And based on that, Xendee will build this chart. So this is basically when the vehicles are available to charge at the facility. So down here is when they're out on the road, when they are not available. The rest of the time, Xendee can choose when it makes sense to charge them. So in this case, there's quite a bit of flexibility because of the example that I put in. And maybe the last one I'll touch on before we start looking at the results together is the ability to model an outage or resilience. So resilience has been coming up a lot, especially in the last couple of years. So what happens if we are grid connected, but we have an announced or unannounced utility outage? Some customer operations are more critical than others to stay online, and that has different economic impacts depending on what they're doing. But that's been coming up more and more lately. So more often than not, when we look at a microgrid solution, we want the ability to do island capability, either ride through an outage or just at least be able to operate during an outage, a utility outage, and hopefully at the full site's level versus having to curtail loads or some other operation. So the way that we model that is in the outage tab. And here we can have it kind of pick a random outage, or we can put in, for example, what I did in this example, a specific day and time. So just for the sake of showing an example, I picked the first day of July, an 8-hour outage in the afternoon. And then the other piece that's important here, if we're modeling a microgrid, we can change the amount of solar capability. So if we want to replicate a storm, for example, right, we probably don't have 100% PV solar capability during that time. So if you want to do something more realistic in like a storm situation, it might be 0, or in this case, I put 20%. So there'll be reduced PV capability during that outage that we have to deal with and find a solution for. So that's how we model an outage there. And then we could pick the ability to, when that outage happens, what strategy do we want to take? So ride through it, which would be normally what we try to do with a microgrid. Or the other option could be curtailment. So, okay, we don't have, it's okay to curtail all or some of the building loads or the customer's loads during that time. But ride through is what I had selected for the example. And from there, the next step is really start optimizing. So the way that looks is we go into this tab. We can give each scenario a name, of course, to try to clarify, especially when we start doing many of them. But there are different toggles here. So, what is the goal? And this really, there's no right answer. It depends on what does the customer want to achieve, or what is most important to them. So reducing the cost, reducing CO2 emissions or their carbon footprint, maybe a combination of both, which the tool allows for. Yes, I want to reduce carbon footprint, and I'm willing to pay a certain premium for that, but not unlimited. We could force the minimum amount of renewable generation as well. And then do we want to consider resilience? With that, there are other things we can do, like force it to have electric redundancy. We do these things in island mode sometimes as well. So quite a few options there. And then the way that we run the analysis, time series, usually when I start, I don't model it as time series. What this means is if you remember when we were building the customer load, Xendee kind of compiles here's what an average weekday looks like in June or July versus a peak day versus a weekend. So if we don't click on time series, it'll model it that way. The advantage is that the optimizations run much faster. So we can model different things and get to solutions very quickly to hone in on optimizations that might make sense. The other one we can do is if we have 8760 data, like we did in this case, we can run it at the customer's actual profile for 15-minute or hour. It takes a little bit longer to run, but then it's exactly how the customer is operating in reality. So then we can show the customer, hey, here's what your actual loads were like last year or whenever they gave us the interval data for, and here's what happens. Here's exactly what will happen if we installed a microgrid, right? So that can be a pretty interesting way to look at it as well. So then we'll go ahead and run it, which I won't do while we're on the screen here, but I will show the results and what comes of that. So I'll start with different scenarios, and I won't click on all of these, but I will tend to run first a reference case without any DRs included. So that's kind of the customer's status quo scenario. If they're consuming this amount of natural gas to power a natural gas boiler, or maybe they have an electric heat pump or whatever, we can model that for however they're operating today without any microgrid. And that can serve as a baseline, so we have something to compare the additional scenarios to see if there's how the economic savings looks, how the carbon footprint savings compares to it, and check the viability of the microgrid. And then we can run all manner of different scenarios. The one maybe I'll show you is the one that I ran in time series with different scenarios that we modeled. So after we run one, the summary page will look like this. So it will show you what technologies are pulled in. So again, we had multiple generators in there to select from. It selected this particular one as the most optimal for what was happening with the customer loads and what we were trying to optimize for, along with the PV that we wanted to be in the project, energy storage, and EV charges as well. So here, high level, it will show us economic savings. So 25% energy savings year over year, and the CO2 savings as well. So about 1,200 tons of CO2 reduction with that on-site microgrid in this case. High-level payback. Again, we can get into modeling PPAs or amortizing costs. In this case, I did a kind of a simple upfront purchase to show the results a little bit more clearly. And then there is quite a bit of information available in these different tabs. So financial data is kind of what you think it would be, but it'll show you detailed financials of before and after cases. So here it shows a kind of a year one scenario. As Lulu mentioned, we could do a multi-year as well and show escalations, but here's a year one scenario with before and after with a microgrid. So the energy costs come down, the utility costs, the electric utility especially costs comes way down. Because we're doing it with natural gas in this particular case, the gas purchase cost comes up because it's being used as a fuel. There's some maintenance costs in there. But overall, there's a significant savings. However, of course, the capex of the project has to get paid for, and that's we find that there's almost always a savings in the project. So then the question becomes, well, what does that commercial viability look like with payback or IRR, or the different metrics that we want to look at it, whether it makes financial sense or not. So here's kind of a nice but simple but nice view at what the payback looks like. So you can see it's just over 4 years in this case, or right around 4, with a simple payback. And then it will give us, again, based on our inputs, which we included kind of rough order of magnitude, but the starting point, it kind of gives us a pro forma essentially for the term that we selected, which was 20 years, but that's adjustable, and it'll show us what the savings look like in the net cash flow during that amount of time. So it's kind of touching on the financial tab. Didn't mean to close that. Another one that's interesting, there are multiple tabs here, but is the dispatch one can be pretty telling. So because I did time series, I can pick any day or week of the year here. So we could look at June 1st, and this is actually June 1st with the customer's actual loads. What's going on here is there's kind of a lot going on the screen at the same time, but the light blue is what the Jenbacher genset is running at. The dark blue is utility import, which I forced a 5% import at all times, which is not uncommon when we're doing behind the meter projects like this. The black line is the actual customer load profile. This green line is when EV charging is added. Remember, it's kind of the off-peak times when it might be charging. The yellow is the solar output, and then the dark green here is the battery discharge. So this is the state of charge of the battery. We can toggle these on and off as well if we want to look at something in particular. And what we can see here is when we add with this load profile, when we add in PV solar, the genset actually isn't running for a few hours during at least on this day. We can look at this through a month or a week as well to check the different load profiles. But this is pretty interesting to see what is going on with the customer loads and what's running when. And if we recall, I think it was July 1st when I selected the utility outage. So if we kind of zoom in on that day, we can see what happens when we lose utility power. So when this dark blue stops showing up, this is the utility outage from 1 to 9 p.m. is when we kind of dictated it. And in this case, it rides through. It does use some of the battery capacity. There is still some solar because we allowed it to use 20% of the solar capacity, we said. If we really wanted to make 100% sure there was a resilient solution, perhaps it looks kind of marginal. We could look at different genset sizing or look at 0% solar to, if it's a must-have. So, but this gives a good view of what's going on during that outage, or what happens if the outage was 12 hours, right? We may want to take a different approach. So the dispatch tab is pretty useful and powerful. Sometimes, especially if we're doing gensets or combined heat and power, I'll look at the operations summary because it will give us a quick glimpse of how efficiently we're using the technology. So, we want to maximize PV solar. We want to, when a genset is running, we want to maximize the efficiency on the thermal and electric side. So we want to make sure it's running normally pretty close to full capacity, which it is. And this makes sense because it's the hours that it's not running. Remember, the 1 or 2 days a week, there wasn't really enough load on site just because of their operation. So, and during those times, the genset would be not operating. So it's kind of is a good way to sanity check it. And it's helpful for us to know, hey, what the genset expected to run 8,000 hours a year, 5,000 or 3,000. It gives us a good idea of that, as well as the capacity factors of any other DER technologies. So lots available on here that we can walk through with customers or show them parts of it or all of it in a report. It will create a PDF report if I go to print here, which is something that you could hand directly to a customer if you chose to do that as well. So again, kind of a lot of capabilities. Maybe one thing I didn't mention, but on the Jenbacher side, we've been using this or myself, I've been using it for almost a couple of years now. The full Jenbacher team have been using it recently as well. And in the genset catalog available, I think there's over 30, maybe over 37 Jenbacher gensets now publicly available to the customer that are in the tool in the catalog and are available to select. If anyone else is trying to model their own projects as well. So with that, maybe I will pause there and head into Q&A.
Great. Thank you, Ed, for that demonstration. And we do have some questions, so I'll let you know for you to kind of take them. So one question would be, how many hours does the Jenbacher 10 megawatt generator need for resting or break time before it can continue?
Good question. So the 10 megawatt unit, if it's, yeah, I suspect they're referring to the 920, and it's I hate to give the it depends answer because there isn't just one answer. There are the minimum time is very short. It could be less than an hour before it can be turned on and off again. Technically, it can be less than that, so it needs a minimal rest. But the number of starts and stops, eventually, it will start having a maintenance impact. So there's a point where if it's up for a few hours and then down for a few hours, it won't really have any maintenance impact compared to the hours-based maintenance. With more frequent start and stops, like multiple per day or multiple in a few hours, which we have operations like that, that is fine as well. It just needs to be accounted for with maintenance practices. So I know that maybe doesn't 100% answer the question, but if you have something very specific, you can email us as well, and we can get a more detailed answer.
And there's kind of like a second question related to that one that asks, does 100% hydrogen mean it run completely on pure hydrogen?
So if I understood the question correctly, 100% hydrogen, yes, we can operate on it right now with some of the engine series. So yeah, all of the full Jenbacher portfolio has hydrogen capability, period. So for 100% hydrogen, there are a few products available right now, commercially available, that can run on 100% hydrogen. Some up to 25%, 20-25%, and across the board, they will reach 100% here in the very near future. So pretty soon it will be across the portfolio.
Thanks.
Yep.
Next question would be, how much do contractors typically charge for completing a Xendee analysis for a grant, for example, for a client?
So that's one, I can't speak for, I guess for others that might be using Xendee, because it can be used for many different purposes and can be, you can model something pretty high level in a relatively short amount of time. So I'll just speak for myself here. If we're working with a customer, we're used to developing projects that maybe take 6 months to develop, maybe take 5 years to develop, and we work with clients that whole time. So if we start having a conversation with a customer and we have their load data, usually we won't charge anything to do a quick high level look and say, hey, this kind of microgrid might make sense. What do you think? Is a payback 3 years? Is it 20 years, right? And maybe not too viable. But if we think a project can make sense and the customer agrees, then there's another conversation to be had on, hey, let's look into this a little bit deeper and do a proper and more thorough analysis to make sure the solution is kind of bankable and makes sense to invest in. And that'll get, for us, that'll get more involved, both in terms of the modeling and spending more time on there, but also probably at some point getting on site and seeing what is actually going on with the customer's thermal side, or how the system can be integrated, where the utility tie-in points are. Try to get a better handle on CapEx costs with engineers of record and contractors to perform the work. So when we start getting to those levels, there's other conversations to be had, and that can be more time intensive and typically would involve a fee of some sort, depending on the complexity. But it depends on the scope, and we can be pretty flexible on what the customer would like to see there and design it accordingly.
Kind of a following up question to that would be how much should people charge for doing a community scale size facility feasibility analysis with Xendee?
Can you repeat the first part of that, Lulu, please?
How much should people charge for doing a community scale sized facility feasibility analysis?
Okay, got it. Well, to be perfectly honest, for like a community level or multi-node or multi-tenant, I myself have done less of those looks or like a district energy kind of look. So I can't speak for others there. I think depends on your expertise and background, right? So we work with partners as well, a lot of pretty reputable engineering firms that will do exactly this kind of work all the time. And the cost depend on how the customer wants to scope it, how detailed they want to get. So I would say purely the Xendee modeling part is one side. It's all a matter of kind of time and effort. There might be more to it as well, developing specifications for different assets, and engineer record kind of work there too. So tough for me on that one to give a specific answer. That gets in a little bit what some of the other parties do that we don't do so much ourselves, kind of on a community level.
Thanks. So next question would be, theoretically, would you bring this feasibility report to a client, then get the project approved by the principal engineering, then move forward to the EPC?
Yes, that's a pretty. There are multiple ways to do it. That's a pretty typical one though. So in the case of a project like this example, we get engaged with where our first contact is with the end user, for example, because we do a lot of work with EPCs and developers as well with projects. But if we start talking to an end user, as in this example, we'll do some looks with Xendee to kind of model some solutions that might make sense. Again, and usually the first step is without going on site, or maybe with a short site walk to get a sense of it. Then we kind of build the feasibility model. Sometimes I'll use parts of the Xendee report and include it with other information. And I always like to show the customers the assumptions we're making and show our work, show the math. So usually in one way or another, yes, I will share the information from the Xendee feasibility analysis with the right assumptions. It all has to be taken in the right context, right? Especially if we're doing rough order of magnitude to start with. If we kind of jointly think, say, it looks like this is something that could make sense, both on our side and the customer side, then typically we'll have a conversation with, it could be different people on the customer side. Sometimes it's engineering. Sometimes it's facilities people. Sometimes it is financial people, like a CFO as well, right? If they're looking at significant investment and trying to see if that makes sense. So sometimes it's a mix of those folks. And then if we really are going to take the project to the next level, modeling again with a rough order of magnitude, the turnkey cost for project is one thing. Executing it and firming it up is another matter. So for that step, our approach depends. If a customer wants us to do it, we will work with local partners. We have, depending on the region and really the application and the scope of the project, we have relationships with good partners that are familiar with our equipment that we've done projects with before. Like, for example, in California, we have quite a few that we trust there, that we may pull into the project with us as a team effort to kind of quantify all those things and firm everything up. Considering with where the interfaces actually are and what is actually going on with electrical distribution system and the thermal system if it's combined heat and power. what do those costs actually look like, right? For the full scope, not just the gen sets or not just the PV, but all of it together. And so, yeah, the way it was described is a pretty typical approach where in a case where we start talking to an end customer, but sometimes they take different turns and approaches as we go through them. It's usually they're usually pretty unique as well.
Perfect. We have some more questions. So the next one would be, how do you prioritize a time series versus a multi-year optimization, and which do you find more valuable?
Good question. So what I showed the time series, I did not show a multi-year example. Usually, and I'm sure other people may do it differently, but in my experience, when I model projects, I'll usually start not with a time series because I'll usually start by doing more iterations of more scenarios in a shorter amount of time, just to kind of get a sense of, okay, which kind of solutions look to be the most optimal for what Xendee's pulling in, and which technologies. Usually I start there. So usually I'll start there and not do time series and not do multi-year. The next one that I will tend to do is, okay, if that's kind of like a rough, very high level, simple payback look. So if that looks reasonable, I may try to get a little bit more granular and put in multi-year, because there I can put in something very real, especially like in the California example I was looking at with PG&E in SCE, a different utility. Utility escalations have been pretty substantial year over year. So the escalation is real, and that makes a multi-year analysis very real, and it can change what a simple payback into a real payback quite significantly by putting in different escalation assumptions for the on the electric utility side. It could be the gas utility side as well. I didn't show the inputs for the fuel, but we can assign values to natural gas, to biogas, renewable gases that we operate on as well as hydrogen. We wanted to model that. So that would tend to be the next one, and then time series. That I like to do when also kind of after the initial look passes the kind of the high level test of, okay, this looks like it could be in a reasonable range. Let's get a little bit more granular, even more. And that's where, like the example I showed, we can show on what's going on exactly every hour of the year or every 15-minute interval data of the year. And that can change the results. I didn't click through our different results, but it usually shouldn't change them drastically, but it'll move the economics around a little bit with the way it compiles the weekdays and peak times and weekends versus doing an actual time series. So when I did that, the simple payback moved, I think it was like a quarter of a year or a half a year, but not insignificant. And if we start looking at resiliency, I really like to do time series because then we want to make sure that a solution is going to be able to ride through an actual load profile and make sure we're not making assumptions there. So multiple ways to approach it, but that's kind of at least how I think about it.
Thanks, Ed. Next question would be, how did INNIO decide the variable maintenance input field was the proper place to model departing load charges?
Yeah, good question. And again, I was getting a little bit into the weeds maybe there when I was showing that. But so for the maintenance of a CHP genset, typically what we will look at for actually the maintenance is a dollars per hour. So it tends to be, at least the way we approach it with customers, it's less dependent on the load and more depending on the run hours. So typically for the actual genset maintenance, we'll do $1 per hour charge, reflective of like a long-term service agreement if we were considering that for a project. And then the variable maintenance, at the moment, the departing load charge, it's a very nuanced thing. To my knowledge, it's only in a few utilities across the US that are doing departing load charges. But so I was simulating that by putting that in the variable maintenance of the genset, which is, it's really not a maintenance item for the genset. What it is a utility charge that they would charge you for kilowatt hours that the utilities is a so-called losing or departing, hence the term, and then gets charged back through a utility fee. So at the moment, that's how I was modeling it. So it's accurate financially, so it works that way. The problem with doing it that way is that if I show a customer like a pro forma, for example, it'll show up as a generator maintenance, and it's actually not. So in speaking with the Xendee folks, they've actually, we're having a conversation quite recently, and they will be looking at it to implement it. So one thing it's kind of a plug for the Xendee folks. Since I started using it a year or two ago, there's been quite a few updates, or when we have a question or catch, hey, could this be implemented? The responsiveness has been quite good, and a lot of development and updates over time, which has kind of made the tool nice to use for us, right? To model all these things. So.
Great. And I guess we're getting to the end of the questions here, but the last one would be, are there any case studies of microgrids designed and built using Xendee for modeling that use case, the INNIO Jenbacher software?
So if I understood it right, any projects actually proceeding from we started working on with Xendee. A couple in the works, and I'll just speak for myself here too, but since we've had it, which has been between 1 and 2 years, I guess we'll say we have some in the works. We do not have any delivered yet that we started modeling in Xendee and executed. But these, I think I kind of mentioned earlier, these can kind of be long lead and long developing, long cycle projects. So like 6 months from a conversation to a purchase order would be pretty fast for this type of project. More often it's 1 to 2 years is relatively typical, and they can go beyond that. So, and then there's a lead time with equipment, and it takes a good amount of time to get equipment shipped and then do the construction and installation. So short answer, no. But given the time frame that we've started using Xendee, it hasn't really allowed for that whole project lifecycle to take place either. So I expect the case to be yes, in a matter of time. So it has been helping us kind of help projects proceed forward and keep them going that way. So versus what we were using before, which was really spreadsheets, as I imagine maybe some other users on the phone may have been doing as well. But those were pretty limiting. It was okay to maybe model one, PV array, PV and batteries, or a CHP unit. But when we start combining things and trying to optimize them, that approach got impossible very quickly. So it's been quite helpful in that respect with Xendee.
Great. Thank you, Ed, so much for the demonstration and for answering all of those questions. We'll share a copy of the slides as well as a recording of the presentation with you via email tomorrow morning. So thank you all so much for joining. Thank you, Ed, for co-hosting with me, and we'll see you in our next webinar. Thank you so much.
Thank you very much.